Welcome to our channel Bright Maths. In this video, let us learn the differences between matrices and determinants. First point, matrices means only arrangement. We can arrange the numbers within bracket. For example, within bracket, we can take the numbers 1, 2. So this is one row. Similarly, here within bracket, we can take 1, 2, 3, 4. Here there are 2 rows and 2 columns. Like that we can arrange the numbers. Whereas in determinant, we can find the value. So the value can be found in determinant by expanding the determinant. For example, take this determinant 1, 2, 3, 4. Here right arrow minus left arrow. This right arrow multiply 1 into 4, 4. Minus left arrow multiply 2 into 3, 6. So 4 minus 6, that is equal to minus 2. This is the value of this determinant. Next, second point, the matrices are denoted by using either this bracket or this bracket. This matrix is denoted by using this bracket. Whereas the determinants are denoted by 2 bars. See this, these are 2 bars. So we have to take the numbers within the bars like this for denoting the determinant. Next, third point, the matrices may be of any order. So the order may be 1 by 2, 2 by 2 or 3 by 2, etc. So here this 1 into 2, we say 1 by 2. For example, see here this matrix 1, 2. Here we have only one row and 2 columns. So this order is 1 by 2. And then this matrix 1, 2, 3, 4. Here we have 2 rows and 2 columns. That means the order is 2 by 2. Similarly, we can have 3 by 2 and so on. So we can have any order. But in determinant, we must have same order. That means the number of rows and columns should be equal. So we must have either 2 by 2 or 3 by 3. We can have 4 by 4 also. So if we have 2 rows, then there must be 2 columns. So like this 1, 2, 3, 4. Here we have 2 rows and 2 columns. So this only we can take determinant. Similarly, if we have 3 rows and 3 columns, then we can take determinant. These 3 are the basic important difference between matrix and determinant. We have some other differences in operations. Let us see that we take addition and multiplication. In matrix, if you want to add 2 matrices, then the order should be equal and we have to add the corresponding elements. That means we have to add this first number and first number, that is 1 plus 3. Next we have to add the second number and second number, that is 2 plus 4. So this gives the answer 4, 6. This 1 plus 3 is 4 and then 2 plus 4 is 6. Next, let us multiply the 2 matrices. For that we use row by column method. We have only one row and one column. We have to multiply this. This is 1 into 3, 3 plus 2 into 4, 8. That is equal to 11. That is the answer. In determinant, for addition and multiplication, we find the value of the determinant. After that, we can add and multiply. For example, consider these two determinants. We have to add this, find the value of this first determinant, and then find the value of this second determinant. For the value, we take right arrow multiply minus left arrow multiply. So right arrow 1 into 4, 4, minus left arrow 2 into 3, 6. 4 minus 6 is minus 2. That is the value of this first determinant. Similarly, second determinant, right arrow 2 into 2, 4, minus left arrow 3 into 1, 3. 4 minus 3 is 1. That is the value of this second determinant. So now we can add this. Minus 2 plus 1 is equal to minus 1. Similarly, if you want to multiply these two determinants, just find the value and then multiply. The value of first determinant is minus 2 into the value of this second determinant is 1. Now we can multiply this. Minus 2 into 1 is minus 2. Next, we have to take common from all the elements. For example, consider this matrix 2, 4, 6, 8. Here we can observe that 2 is common in all the elements. So we can take 2 common from all the numbers. After taking 2 common, we have 1, 2, 3, 4. Whereas in determinant, we have to take common from any one row or one column only. For example, take this determinant 1, 2, 3, 4. Here see this second column. We have 2, 4. In that we have 2 common. So from this second column, we can take 2 common. First column 1, 3. In second column, taking 2 outside, we get 1, 2. Similarly, if you want to multiply any constant, in matrix we have to multiply all the numbers by that constant. Whereas in determinant, if we want to multiply any constant, we have to multiply that constant in any one row or one column only. And then finally, interchanging gives different matrix. For example, consider the matrix 1, 2, 3, 4. Take it as A. Let us interchange this. Interchange means transpose. That is changing rows into column. That we denote it as A power T. So here T means transpose. Interchange rows and columns. Here the first row is 1, 2. We can write it as first column 1, 2. Similarly, this second row is 3, 4. We can write it as second column 3, 4. And now these two are different. But in determinant, the interchanging doesn't alter the value. So if we interchange rows and column, we will get the same answer only. Take the same numbers. This A matrix 1, 2, 3, 4. For that we take determinant. So determinant we take within 2 bars. That is determinant A equal to determinant 1, 2, 3, 4. And this value is minus 2. Right arrow multiply minus left arrow multiply. That is 1 into 4, 4 minus 2 into 3, 6. 4 minus 6 is minus 2. Next, let us find the value of this A power T determinant. So determinant A power T, that means interchange rows and columns. First row 1, 2 is first column. Second row 3, 4 is second column. Now for this, if we take determinant, we get the same value. Here right multiply 1 into 4, 4 minus left multiply 3 into 2 6. So 4 minus 6 is minus 2. We get the same value. These are the differences between matrices and determinants. Thanks for watching.